Good afternoon, everyone. Really appreciate everybody taking their time this afternoon to join us for the Meritor Foundation Brake Review Technology meeting this afternoon. Presenting this afternoon, we've got Rick Martin and Paul Nyers from Meritor. I am quite certain that everyone is going to enjoy this and grab a wealth of information from today's webinar. With all of that said, I don't want to delay this any further. I'm going to turn this over to Rick and Paul.
Well, hey everybody, go ahead and advance it, Gina, please. That's what we're going to talk about. Let's go ahead and advance it again. No reason to go over what we're going to talk about since we're going to talk about it. But this is what I do want to start off with. There are three major publications from Meritor that will support this training that we're doing this afternoon. I'm going to talk a lot of technical information that, again, with a presentation like this, you're not looking at me. You're at your desk, maybe doing other things that's going on. So all of the information that I provide you are going to be accessible in these three publications, which are TP 1363, that's Inspecting Commercial Vehicle Foundation Brake Systems, which is the more of a preventive maintenance type of publication. Then the 0879, you're going to see that. It's a colored one-page, two-sided publication by the Federal Motor Vehicle Safety Standard Administration. We'll talk about that in more detail. And then, of course, the Maintenance Manual 4, which is a Meritor publication we've had for, 80 years or something like that. That is our cam brake and automatic slack adjuster pub. So as we go through this, I will point out in many cases where these are found in those particular publications. So when we're done with this, now here's the first one, the 1363. And again, I'm not going to read everything here, but it basically is a wheels-on and wheels-off inspection criteria bullet pointed for each item in a foundation brake system. Now, that doesn't relate to the air system, which ought to be inspected while you're doing a PM, but this covers the mechanical part of the foundation system. It doesn't give you complete specifications for things to check, but such as dimensions. That can be found in, of course, Maintenance Manual 4. But it gives you a nice overview to build a nice PM program off of. And then the last bullet point, understand that to protect you liability-wise, you should have all of your brake repair technicians, anyone that performs brake inspections or repairs on a commercial vehicle must be qualified as a brake inspector under the Department of Transportation Commercial Vehicle Safety Alliance. Next slide, please. We're going to start with the brake free stroke and then get into the chamber applied stroke. And this is taken directly off of course, TP 1363, working in that order. There's a lot more in that TP that I'm not going to talk about, but I'm talking about the highlighted things that I think are important for this particular presentation. Next slide, please. If you have questions throughout the program, please don't hesitate to ask. We'll also have questions and answers at the end. Well, we'll have questions. I'm not sure we'll have answers, but we'll have the questions. Brake pre-stroke. This is using TP 0879. It is a Federal Motor Carrier Safety Administrator publication, even though they didn't create it. What the FMCSA did is they demanded Meritor and Bendix to create a publication for commercial vehicle drivers in order to properly understand and properly inspect brakes before and after their trips. So this one-page publication has a lot of supportive information for a technician, not only for a driver, but very much for a technician. It talks about how to do a free stroke, how to do a chamber applied stroke. It talks about how to identify a brake chamber type and a brake chamber size. And it gives specifications for both standard and long stroke brake chambers when doing a preventive maintenance inspection on a chamber applied stroke measurement. Next slide, please. So let's talk about free stroke a little bit more in depth, and this slide here will help us with that. And it shows the slack adjuster, and a pre-trip inspection is required by law for commercial vehicle drivers, where on an air brake vehicle they're supposed to grab the slack adjuster and pull it back to check free stroke. The specification per the CBSA is 1 inch. We say it's a half to 5/8. You know what? It depends on how strong you are. If you really pull hard, you might pull 1 inch. If you pull a little softer, you might get a ½ inch. So what does free stroke tell you? Free stroke is basically a measurement at the slack adjuster and clevis that relates to the 30,000ths of an inch between the lining and drum. What is it? It's basically the clearance of the running clearance of that lining to drum as the vehicle's going down the road. So what does this quick check tell you? The quick check of free stroke tells you, number one, your brakes are not over adjusting and they're not too tight. You have to have some free stroke, and we're saying it ought to be around a ½ inch, but it could actually be less than a ½ inch, as long as those linings are not hitting the drum at all times, and you've got a gap. What you don't want to do is during a PM or doing a pre-trip inspection as a driver, you don't want to grab the slack adjuster and have it move 3 inches. If you have it move 3 inches and it's a long stroke size 30 brake chamber, you're bottomed out. So that means you have no brakes on that wheel end. So it's a quick check to really kind of verify that the slack adjuster, being automatic, which is required by law, and the brake system, the foundation brake componentry, are functioning correctly during service of that vehicle. So it's a quick check. And the bottom bullet point tells you something here, that the check is not recognized by the Commercial Vehicle Safety Alliance as a reliable source for brake operation. And I'll explain that here in a moment. However, it's a nice quick check during a PM or for a technician before he does a brake job. And here's why. Yes, thank you. Go ahead. That's fine where it's at. If a mechanic or technician is going to do a two-wheel end or four-wheel end brake job, that person ought to know where he or she is starting from. I would recommend, before they do the brake job, to do a free stroke and or chamber applied stroke. Because if you grab one of them and you move it 2.5 inches, you know that you've got more work to do on that one wheel end because it's not maintaining adjustment. But if you grab all four and they're all within the free stroke of less than an inch and you've got good chamber applied stroke, you know that the system is functioning correctly. You just need to replace the worn components. Now, here's the other usage of TP0879 on the left-hand side, applied stroke measurement. This applied stroke can be also called the power stroke or chamber applied stroke. And continue on, Gina, please, the next slide. And I'll continue to talk while the slide's being loaded. The chamber applied stroke or applied stroke, if you look there, the top bullet point says you should be doing it at 90 to 100 PSI. Now, just to let you know that the majority of brake applications, and again, I have different folks on the line, bus, coach repair, truck repair, tractor repair, maybe even trailer repair folks. But take an 80,000-pound tractor trailer. You have over 120 pounds of air pressure available to stop that vehicle. 99% of the stops of that 80,000-pound tractor trailer are done below 20 PSI. So most brake applications on a tractor trailer are anywhere from 8 to 20 PSI, and they average around 12 to 14. Now, so if you're looking at a bus and coach, you're talking about the same thing. So the question is, wonder why the CBSA wants you to do it at 90 to 100? Well, what I talk to mechanics about is what the CBSA is trying to do is do a dyno test on the foundation brake system. They're wanting to see in that panic stop going down that long hill in West Virginia or Colorado or anywhere where there's down in Georgia, they want to make sure that when that driver applies those brakes at a full brake application, that all those wheel ends will perform correctly and it won't stretch a chamber bracket, or a chamber that's loose will pull the nuts right off of the studs, or the camshaft twist to where no more brake torque is being applied to the brake lining and drum. So what the DOT is doing is a very abnormal air pressure application, but they're doing it just to check out that system at that higher pressure. Now, what's critical about that pressure is when you're doing a chamber applied stroke, it must be done between 90 and 100 air tank pressure, which is gauge pressure. If you're at 120 to 130, you've got a problem because you're going to overstress the components and you may fail the test by overstroking. So you always got to make sure that the technician, the CDSA inspector, driver are all aware that 90 to 100 is the specification. Now, we've actually seen customers, fleets, come to us at Meritor and say, we got a ticket because the brake was out of spec, but we brought it back in the shop and it's fine. And we can only attribute it to the inspector forgot to pump the brakes down to 90 to 100 psi of tank pressure, and he had the driver just apply the brakes at full rated governed pressure. So we've got to be careful of that. Next slide. So why is the applied stroke pressure range 90 to 100? Well, we've already told you, primarily because they want to do a dyno test on the foundation brake. But and it's the required pressure, so we got to do what they tell us. But anything beyond 100 psi, as I said, measures deflection within the foundation brake system is not true pushrod stroke. So that's why they're doing that. So again, that's just to confirm what I said on the previous slide. Next step, please. And these pictures here are actually taken out of Maintenance Manual 4. And they're also on the one side of the TP0879. Okay, now. One of the questions you might, as if we've got directors of maintenance, we've got service managers, and I'm sure we have some technicians online, but a good question to ask one of your service technicians that's qualified brake inspector that's doing brake repairs is give him or her a little quiz. Say, let me give you a scenario. You're doing a chamber applied stroke check, and you've got your system set up at 95 psi. And you do a full brake application after measuring the at-rest position. Now you measure the full brake stroke position, and you subtract the two. And let's say I get 2¼ inches of stroke on this particular wheel end. Am I within DOT specs or am I not? And what I find is when I challenge technicians on that question, I'll get, oh yeah, you're out of spec. You got a problem. And some will say, I don't know, or just shrug their shoulders. And then I'll say, no one can give me the correct answer because I haven't given you enough information. The reason I say that is if it's at 2¼ inches and you have a size 30 standard stroke chamber, yes, you are beyond the 2-inch CDSA limit in the out-of-service manual. If it is a long stroke size 30, you're within specifications because the spec on that is 2½ inches. So again, what's important? The important part is the technician must be able to understand how to identify a brake chamber. What does that mean? You got two ways of identifying a brake chamber, or two criteria, and that is type and size. So looking at this particular chart, we see on the top of that chart where that red circle is, that is a standard clamp type brake chamber. On the bottom is a long stroke, and they have the chart that shows the rated capacity of that brake chamber and what the maximum is by CDSA. So if you have a fleet of vehicles that are all the same units, so you got 20 vehicles that are all sister units, and the technician only works on those 20 units, then that technician's going to know the brake sizes and types on all those vehicles. That's simple. But if you have a repair facility where you have different vehicles coming in all the time, the technicians don't know what is on the back axle of that particular unit or the front axle of that particular unit. So they have to know the difference between a standard stroke, long stroke, and an extra long stroke brake chamber and know how to identify the size. So that's critical. We'll talk about some of that here. Now, I talk a lot in this program about brake chambers. Meritor has not ever and does not manufacture brake chambers. We buy them from sources like TSC, Haldex, and MGM. We do make everything else for the brake system, whether it's air system components or foundation brake components, but we don't manufacture brake chambers. So why do I talk so much in depth about brake chambers? Because they have such a critical effect upon my brake system, and when I'm doing brake training, shame on me not to include that so the technician will understand and know after he does or she does a brake chamber applied stroke how to properly calculate and verify that he or she is within specifications. And then on the bottom of this particular screen on the right-hand side, you'll see a brake chamber, a service chamber, with an orange band on it. That's law. That's a recommended practice by the Society of Automotive Engineers that says that any chamber that's brought into the United States and put on vehicles that are going to be on U.S. highways or Canadian highways, they must have a red or orange band that will identify to the technician or driver when that band starts to appear beyond the face of the brake chamber. It tells them that they're getting into the maximum stroke of that particular brake chamber. So again, that's a quick identifier if a technician is not taking actual measurements and just looking at the push rod as the push rod is extended during the brake application at 90 to 100. Next slide, please. Now, I can't guarantee that every brake chamber is going to have a band on it like that, even though it's a recommended practice by the Society of Automotive Engineers, because we do have a lot of gypsy parts coming in from different parts of the world, and sometimes they don't abide by our regulations or don't know to. So this slide here is basically telling you that by using TP0879, not only does it tell you how to do a free stroke, how to do a chamber applied stroke, but it also shows you what specifications are for a standard chamber and long stroke chamber and how to identify each one of them. Okay? These publications are free and available to anyone that would like to request. So if you have a request for any of these publications, throw an email to Gina and we'll get it handled. Next slide, please. Okay, now we're looking at another chart similar to the one on the previous page and the previous page there. But what I wanted to point out here is, and I think there's a slide coming up that really points this out, but I think you heard me mention that there's three types of chambers. There's a standard chamber, a long stroke, and the industry has used this term off and on, an extra long stroke. I'd like you to look at the top arrow, red. It's pointing to 24, and that's a standard brake chamber because the brake adjustment limit is set at 1 3/4 inches. That 24 size chamber for a standard stroke chamber has a rated stroke of 2 1/4 inches. So 2 1/4 minus a half is 1 3/4. That is a standard chamber. Now look down at the next arrow coming down, and you've got a 24L. That's a 24 long stroke. It's a 2 1/2 inch brake chamber, and its rated stroke, it's at its rated stroke, and the limit by DOT is 2 inches. There is what we call an extra long stroke, type 24 or size 24, with the asterisk on it. It's 2 1/2 inches is its limit because it's got a 3-inch rated stroke. So right now, I've done my research with both NGM and TSE, and I haven't seen any other brake chamber like a 30 or a 20, which is the most we see on our vehicles today, that have those three types, standard, long stroke, and extra long stroke. But I'm seeing a lot of vehicles now being built with extra long stroke, size 24 chambers on the front steer axle. Now, why would that be? Because if you got a long stroke size 30 on the rear drives, it has a 3-inch rated stroke. Now you have an equal 3-inch stroke chamber on the front. So you've got all 4 wheel ends or all 6 wheel ends with rated strokes of 3 inches. Why do you need more rated stroke? It's just a precautionary measure. If you're going down a hill and you start gaining speed, heating up the brakes, and applying more pressure, the more stroke you're going to need to stop that vehicle, especially if you're not using quality brake linings or the drums are expanding because they're too thin, things like that. So most brake applications, the stroke is around 1 1/4 to 1 1/2 to 1 3/4 inches. So you're never out to 3 inches. However, in a panic stop or going down a long, long hill, you may need that extra 1/2 inch of stroke or so. So that's why a lot of the OEs are going to the 24 extra long stroke to have 3-inch stroke at every wheel end. Next slide, please. Just as an FYI, if you had a vehicle that, and we're talking part sales here now, but part sales, but also giving you some peace of mind, some insurance, if you will. If you had a vehicle that had all standard stroke chambers, and let's say the front axle was a size 20, and the rear axle drive axle was size 30, and they're all standard chambers, you could upgrade all four wheel ends to long strokes, or even the front steers to, you couldn't go to extra long stroke because a size 20 doesn't make an extra long stroke. My point is, you can change a standard to a long stroke in service without affecting the brake balance, as long as you stay with the right size. So that means if you got a size 20 standard, you could upgrade to a size 20 long stroke and be fine. And you're giving the customer that extra half inch of stroke if he or she needs it. So that's just as an FYI. However, don't mix. Never mix brake chamber types side to side on an axle, and that would be long stroke, standard stroke, or extra long stroke. Don't mix sizes. Don't put a 30 on one side and a 24 on the other. And I think we're all pretty educated that we understand that's a brake balance issue if you do that. But the reason you don't want a long stroke and a standard stroke on the same axle is because now that we have the Federal Motor Carrier Safety Administration with their new law enacted in 2010 called Compliance, Safety, and Accountability, they can actually ticket you for having a long stroke on one side and a standard on the other, where until 2010 there was no regulation in the out-of-service manual for that. You could actually have a long stroke on one side and a standard on the other, and not be not get in any trouble for it or ticket. I'm looking here. Okay, we already talked about this. This is talking about anything over 100 psi. You have true deflection in the brake system. That's why you want to maintain 90 to 100 when doing chamber flight stroke. Next slide, please. Again, I'm covering a lot of information in a short period of time. If you have any questions, ask them. If you don't have questions, don't want to ask them, you got 3 publications that you can refer to. This basically is just a slide that I've already covered, so keep going. All right, what is the next slide? The next slide is going to talk about, oh my gosh, this is really, wow, an eye chart. All right, take your time here. Take a look at the left side. It says force output. Take a look at the bottom. It says stroke. What I want you to look at is not to worry about the numbers on the left side, the 500,000, 1,500, 2,000. Who cares about that? What this chart is showing you from MGM, and CSC has the same chart, is it's showing the comparison between a standard brake chamber and a long stroke. A lot of questions have been asked about why is the industry going to long strokes? What is the advantage? Well, this shows what it is. If you look at the red line and black line as it starts out from 35 from the left-hand side and goes all the way horizontally to the far right side, you notice that the red line is almost linear, and it ends up at 3 inches on the bottom of the chart, which shows stroke. If you look at the end of the black line, it goes to 2.5. What this chart is showing you is a comparison between a standard size 30 brake chamber and a long stroke size 30 brake chamber. Now what I want you to do is look at the 2-inch at the bottom of the screen, then take your eyes up the 2-inch line and look at where that 2-inch line meets the red and the black line coming across. From that 2-inch down to 0, those 2 lines are virtually equal. That means a normal brake application of 1.5 inches of stroke, it doesn't matter whether you have a standard or long stroke chamber at all, because they virtually put out the same amount of force. However, when you get to almost 2 inches, the standard chamber starts dropping off in force output. And of course, a standard size 30 has a rated stroke of 2.5 inches. That means it goes no more than 2.5 inches physically. That's where it's locked up at. So if you look at the amount of force that drops off, it starts at 3,500 and it drops off to 2,250. So it drops off quite a bit at the end of its stroke. Look at the long stroke. It maintains almost an equal amount of force all the way to the end of its stroke, which is 3 inches. So So what's the advantage of a long stroke versus a standard stroke chamber? Next slide, please. Well, by looking at this chart, and if you listen to me very well, the first bullet point says the long stroke chamber provides higher push rod force at or near the recommended readjust position than a standard chamber. And then, of course, the last bullet says the long stroke chambers increase the available stroke. So you're just, it's a, what's the term I'm looking for? It's a nice, I'm lost. It gives peace of mind that you've got extra stroke if you need it. That's what and I'll tell you what, I've seen in the last 5, 6, 7 years, more and more, the majority of OEs, I don't care if they're Bluebird, Freightliner, whoever it might be, they're virtually all going standard with long stroke chambers. And it's primarily because they want to really kind of put the best out there so there's not a liability issue. And we know there's going to be accidents. We hate to say that, but it does happen. Now, according to this screen here, just to let you know, I talked about two SA recommended practices in this program. One I've already talked about, which is the identifier of that orange and red band. This is, of course, when the long strokes came out about 15 years ago, and again, they were very, very scarce at the time, but they've grown, of course, dramatically since then. The Society of Automotive Engineers put out another recommended practice, a J1817, and it's a paper about 5 pages long that says, you know what, if you're going to make a long stroke chamber and you're going to sell it in the United States, you're going to have some forms of identification to help the technicians. There are 3 forms of identifications. Most of you already know that some of them have square airline bosses. They also have what they call a trapezoidal tag, and they also have a permanent stamping on the metal can. Now, the problem with these 3 things is, number 1, the item number 3, permanent stamping on the can. You will normally not be able to read it after the vehicle's been in service. Also, there is no permanent marking requirement, meaning there's no standardized requirement saying it should say long stroke, or it should say extra long stroke, or it should have an L behind it, or it should have a big L on it. There's nothing that says that. So some chambers are going to say a long stroke on them. That's easy. Some will say only use a 3-inch diaphragm for this chamber. That doesn't really say it's a long stroke. It just says you got to use a 3-inch diaphragm. Well, again, most long strokes are 3-inch rated strokes, so that would be the 3-inch diaphragm. But it's not real clear. Next screen, please. The other thing, too, is this Society of Automotive Engineers paper tells the manufacturer they only have to use 2 of the 3 identifiers, except all size 30 chambers built and sold and installed on U.S. and Canadian vehicles must have square airline ports or a square identifier by the airline port. And we'll discuss that in a minute. Here's something that you've probably seen more and more, and that's a good old spring brake chamber from MGM with the square airline ports. Very easy to identify. The other thing is, on the left-hand side, you see the trapezoidal tag. It's trapezoidal. It's not a rectangle. It's not a triangle. It is a trapezoidal. It's shorter on one end and wider on the other. And on that, the nice thing about the trapezoidal tag that I tell technicians, the tag is pretty hefty. It's plastic, but it's very flexible. It should be there the life of the vehicle. Again, should. But it's real nice because it tells you the rated stroke on it. So if you were to read the tag and you had a size 24 brake chamber and the tag said 2.5, you know that you'd have a long stroke size 24. If it was a size 24 and it had a tag on it, trapezoidal, and it said 3-inch, you'd know it was an extra long stroke. So there it gives you a the quick information of what stroke it's rated at, and then you can determine mostly about a half-inch beyond or from that is what the DOT spec should be. Next slide, please. The next slide shows the standard on one side and the long on the other. Continue the next one, Gina. And the size difference on this slide, it's not right because they're not that much difference in size. Here, the only a spring brake chamber is a little bit easier to identify because most rear drives on most trucks, tractors, buses, coaches, or cam brakes are size 30. That means they were required to have square ports. They're easy to see, so that's kind of a no-brainer. However, front steers and tandem axles, where we've only got one set of spring brakes, you're going to have service brake chambers. The service brake chamber, to date, I have never seen a service brake chamber long stroke with a square airline port. If you look at this picture, this is an MGM chamber. It's got a round port welded to the case of the can, both on the top and on the side here. And, of course, the OE is going to connect whichever one that is easier for them to route their line. But you'll see the trapezoidal tag, and I can't read it. I don't know if it says, I think it says 2.5 inches. So that would be probably a size 24, 2.5 inch raised stroke. But also, if you look at the bottom that I've circled there in yellow, it's kind of like a trapezoidal can stamp in there, and on that it says something about the stroke. So MGM has told me, again, everything can change. But when I was down there last year at their headquarters in Charlotte, North Carolina, they told me that they want to cover things 100% by the SAE standard. They're telling me that every MGM brake chamber that's long stroke will always have all three identifiers. However, I've seen other manufacturers that only have 2 of the 3 identifiers. But MGM has told me they want to use all 3 just to make sure they cover themselves. So, next slide, please. Yeah, okay. What is this showing? It just shows that the TP0879 and circled there in red on the left and right-hand side, in text, it tells you how to identify a long stroke versus a standard brake chamber. And then at the top, it shows a tool that you can actually measure the clamp band to determine the size. So next slide, please, and I think that's the tool that we're going to talk about. Remember, this card was developed for drivers as a driver visor card. But what I saw a real advantage to pass this card out to each brake technician that you have in your facility so that he has a quick reference or she has a quick reference. Now, here's that tool that used to be called Chambermate. They changed the name. It's called a brake chamber tool now. It's available. A guy mass produces that down in Dallas, Texas. It has 3 things it'll do. It'll identify the chamber type and basically that size. It's got 3 points on it, and you lay it against the clamp band, and it just physically moves the pointer to identify 24, 30, 16, or whatever it might be. And then it shows you the push rod travel. And how does it do that? On the opposite side of this that you're seeing, it's got a measurement, incremental measurement in inches. I think it goes to like 3 inches. That's on that flat end on the left-hand side there. And then on the long stroke identifier, if you look at the left-hand side of that tool, it's kind of flat and square. Well, if you can fit that into the clamp bands of a spring brake chamber, and that tool doesn't touch both clamp bands, it is a long stroke chamber. Again, the tool would be nice if you had a shop that was working on all different types of equipment all the time, and you know, some chambers are hard to identify because of the corrosion and things like that. So next slide, please. I'm not selling this. I don't make any money on it, but this is a tool that all the DOT inspectors use that tool. Now, we will talk about one more item here shortly related to identifying of a long stroke chamber where you don't have to use that tool. An actual tool that Meritor has and has had for probably the last 35 or 40 years. We'll discuss that when we get through here in a minute. Let's move on to automatic slack adjusters. Everybody knows they're required by law since October of 1994. I say automatic slacks, automatic brake adjusters by law, but we know on cam brakes we use automatic slack adjusters. Meritor on the top slack adjuster, you all recognize that. That's the Meritor stroke sensing. And on the bottom right-hand side, that looks like a Haldex, but that's actually a Meritor clearance sensing. There are 2 types of slack adjusters out there. A stroke sensing that senses stroke on the application, and clearance sensing that senses clearance on the application. Meritor is the only stroke sensing. Everyone else, Stemco, which is a Crucian Bruner, Gunite, Bendix, and Haldex are all clearance sensing. Is there an advantage or a disadvantage? It depends on who you talk to. They all work. As long as you install them correctly and you keep them lubricated with the correct lubricant, a slack adjuster will last many, many miles, many, many years. So there is no better or worse slack adjuster as long as you maintain them and install them correctly. Next slide, please. There is an advantage, we think, to Meritor, and that is it is stroke sensing, because we sense stroke, which is exactly what the CDSA looks at. They're sensing stroke, and yet the others are sensing the clearance between lining and drum. But the interesting thing is, in tests being performed by independent laboratories, they all do a very good job, and they all maintain about a 30,000th gap between lining and drum. So really, it's dependent upon what the customer really likes. So next slide. This slide I've kind of already talked about. We have a video that we're not going to show because it doesn't show very well within our system here that our webinar. So that is available. This program is going to be available to you on YouTube and from the Bluebird website, and you can show that video. And I really recommend it because it shows in detail how my slack adjuster works throughout the process of application and release. And something I want to bring up while I'm talking about that, the majority of slack adjusters out there, the two that really are the biggest population are Meritor first and Haldex second, and they're close first and second. And then there's everybody else. I think you're all aware of that. Oh boy, where was I going with that? Sorry, I lost it there. The two, Haldex and Meritor, the biggest population, they both function in a similar manner. I don't say they're built the same way, not at all, but they function. And what does that mean? They measure the stroke and or the clearance, so they measure brake adjustment on the outward stroke on the application. They make the adjustment on the return. So let me point out something to y'all. If you have a wheel in that comes in that's out of adjustment, don't always blame the slack adjuster. If the slack adjuster isn't returned all the way back, how does it return? Two return springs return it. One in the chamber and one in the brake shoes. If those springs are weak or broken, that camshaft may not come all the way back, won't bring the slack adjuster back, whether it's mine or Haldex, and you have a wheel end that will be out of adjustment. So you've got to check the entire foundation brake system if you have a wheel end that's not adjusting correctly for looseness, for broken springs, or even if the springs are not broken and not weak, if you have a camshaft that's partially frozen in the bushings, that will maintain enough resistance that the slack may not come back all the way, and you won't have an properly adjusted brake. So putting the new slack adjuster on that particular brake is not going to fix it. So please understand that it takes more to diagnose than just replacing the slack if you have a wheel and it's out of adjustment. This is another ruling by the Federal Motor Carrier Safety Administration. You are never to adjust a slack adjuster, automatic slack adjuster, in service on a vehicle if it's out of adjustment. You are to diagnose and repair the system, just as I explained. Next. We're going to talk a little more detail about identifying and putting on the right slack adjuster when you're replacing a Meritor slack adjuster. So you've done a service, you've verified that the slack adjuster is no longer functioning. So you're going to put a new one on. You've got to make sure you put the right handing slack adjuster on. We're the only ones that have a pawl. That pawl is the automatic adjustment device that slides onto the sleeve inside the slack adjuster. And there's three positions for that pawl. You have the handed and unhanded. That's two. Oh, you have a right hand and left hand. So that's three. actually, we don't call it right or left hand because it depends on how you're looking at it. So if it's on the side of the slack adjuster body, we call it handed. If it's on the front of it, it's called unhanded. Whatever you take off the vehicle, put the exact one back on, because if you put the wrong one on, the wrong position of the pawl, it could possibly hit a suspension component on that vehicle, and that might limit the travel of that brake wheel end, and there's a liability problem. And the brake adjuster won't adjust correctly. So make sure that when the parts department or the WD or dealer provides that part to you, that the technician is responsible for putting on the correct part on that particular vehicle. Next, now, if you run into a bind and you can't find the right-handed one, I think correct-handed one, if you have all the room in the world, like on a trailer axle, and there's nothing in the way, it doesn't matter which position that paw's in. So you can always put a handed on an unhanded that was already on there, or vice versa. On the very top of this picture, it does say Meritor slack adjusters are brake and chamber specific. We actually applicate our slack adjusters by brake size and type, cam versus air disc, and chamber size. So next slide. This is just out of Parts Book 8857, just showing you that, but the detail I don't need you to look at. This is something that only Meritor has, and you better be well aware of it. It's also pointed out in detail in Maintenance Manual 4, so if you wanted to read Maintenance Manual 4 after our presentation, a lot of this information will support what I talked about and reinforce what we've gone through today. Every one of our stroke sensing slack adjusters has a piston inside. We have 5 different pistons, and if you look closely, we have them in blue, green, yellow, red, and black. I think at one time we had other colors, but that's what we kind of settled on. What's the difference? The difference is this little tiny piece of plastic that would fit into a smoking pipe, okay? It's different heights. The height of that piston controls when my slack adjuster makes an adjustment. So the shorter the piston, the longer the stroke's going to be before it makes an adjustment. The taller the piston, the shorter the stroke's going to be before we make an adjustment. With that being said, if you took a short piston off and you put a long piston on, and I say not just a piston, I'm saying you're replacing the slack adjuster with a short piston inside it, and you put the parts bike gives you the wrong slack adjuster, incorrect slack adjuster, everything's correct except for the piston size, and you put it on, that brake is going to over-adjust. That brake's going to get tight, it's going to get hot, and you just induced a problem into that system. So, how do you know what color piston you have on your slack adjuster when you're replacing a Meritor with a new one? Next slide. We have a Mylar tag on all of our slack adjusters, whether it's a production slack adjuster or aftermarket slack adjuster. And honest to gosh, most of the time, they're still there after 5, 6, 7 years. They may be covered up with grime and grease and undercoating and paint, but they're still there. Now, if you look at the top of the Mylar tag there in red, it says T2430. What does that mean? Well, that's type 24 and 30, which I think is not type, but size. Size 24 and 30. The DR stands for drum brake versus air disc. And YEL, this is the key point, stands for yellow. If it was red, it would be RAD. If it was blue, it would be BLU. The 2 most common colors that we have in the industry are red and yellow. However, we do use green and we do use blue, so you've got to know what you've got. So, let me ask you this. You're changing a slack adjuster. What are the things you need to know to the parts department to get the proper slack adjuster? Number 1 is the length. 5, 5.5, 6, 6.5, 7. Most common is 5.5 on most vehicles today. That's measured from the center line of the clevis, the large clevis pin, to the center line of the camshaft. Then you have to know the spline count and size. which is common sense because if you get the wrong one, it ain't going to fit on there anyway. However, now you need to know is it handed or unhanded, and what color piston, which is the most important part when you can't see it. So you've got an old slack adjuster you pulled off of this wheel end, and you can't read the tag because somebody's damaged it. Okay, you know you're going to replace the slack adjuster, so rip the boot off and look down inside, and you'll see the top of the piston. Wipe it down with the rag, and you'll see the color of the piston. It's either going to be red, yellow, blue, green, or blue balloons. I think it's Wonder Bread. I'm not sure. But anyway, so rip the boot, look down in there, and see what color piston it is. When you get the new one from the parts department, you, as a technician, have to verify they gave you the right one because that technician is also responsible for the correct parts on that vehicle. So, and again, he doesn't want to tear the boot of the new one. He doesn't have to because he's going to get a new slack adjuster. It's going to have the YEL or BLU written right on that Mylar tag. So he can verify that or she can verify that. Next slide. All of this is pointed out in Maintenance Manual 4. Okay, next slide says, oh my gosh, there are two different clevises out there. And when I say that, you probably say, well, we knew that. There's a single hole clevis and there's a dual hole clevis. No, there are two dual hole clevises now and have been for about the last 12 years. When the long stroke chamber came out, we looked at it and said, all of a sudden now the slack adjuster is going to go out another ½ inch, possibly in a long downhill run. And meaning it'll go from a rated stroke of 2.5 to 3 inches. That's going to lead to a problem maybe in some cases where that slack adjuster could actually contact a suspension component. And if it does, we've lost braking and torque on that wheel end. So we're going to have to move this slack adjuster back a little bit in order to allow it to clear any components in there. So to do that, we actually changed the position of the holes in the clevis. So up in the upper right-hand picture there, which is the line drawing, that's taken right out of Maintenance Manual number 4. There is a 1.30 clevis and there's a 1.38 clevis. So any of the dual clevises, dual pin clevises, you can't just look at it physically with your eyes and say, yep, that's the right one. You can't see 80 thousandths. There is a tool that I have that you will be able to use to determine which one you have. Because it's even hard to take a measuring caliper and measure between the two holes and determine the 30,000 or the 80,000 difference, excuse me. So let's continue on to the next slide, and we're going to talk about this in much more detail. And while I'm thinking about it, don't look at this slide right now, just listen to me. While I'm thinking about it, I think you'll notice that many of your vehicles today are coming with brake chambers that have what they call welded clevises on there. The welded clevis became popular about 6 or 7 years ago when the OEs came to MGM and said, instead of us installing the clevis, why don't you install it, weld it, and set it at the right position? That way when we install it on the vehicle, we don't have to make any adjustments. It saves us time and money. So the welded clevis is set at a particular slack adjuster position or dimension, which we'll show you a little bit later in the program. And enough said there. We'll discuss more about welded clevises in a moment because it's critical to talk about that. This particular slide right here basically shows that my slack adjuster has to be set up at a certain angle. No different than when you set up a Haldex slack adjuster, the old Haldex, not the Saba, that you had with the bracketry, the old Haldex that you had to move the pointer into the slotted area of the slack adjuster, that's setting up the slack. And that way, once it's set up, the slack knows that you've set me correctly, now I will maintain a 30 thousandths gap between lining and drum. My slack doesn't have a bracket, but it does require a certain angle of setup. That's 101 degrees, according to this picture. However, if you look at the bullet point, second one there, it says the angle should be 101, 105, or 107. Now, I've really confused you. 101 degrees and 107 degrees, those are used for trucks, buses, coaches, tractors, power units. Trailers use 105 degree working angle. Okay? Now, how do you measure that angle? You have no square right angles on my slack adjuster, so you can't use a protractor. Next slide, please. using here that kind of reinforces what I mentioned on the previous slide. But look at bullet 2 and bullet 3. Less of an angle, 90, 95, you're going to create a tighter clearance. That means you're going to have possibly a tight break. More clearance, 120, 125, so more of an angle, will make a greater clearance. So my point is, if you install a new brake chamber and don't set the clevis at the right position, my slack will not function correctly. This is no different than a Haldex if you don't set the pointer into the slot. Next slide, please. Now, the top 3 pictures on the right-hand side are templates. I think most of us that are on this phone call, this conference, can identify that. Those are the automatic slack adjuster templates. When you buy a slack adjuster from us, you open the box and you get a booklet in there that tells you how to set up the slack adjuster. It also gives you templates you can tear out and use. Years ago, we made these templates in the aftermarket out of plastic. We don't do that anymore. They're out of cardboard, but they're a little hard cardboard. That way they're not so flexible that you can line up the 3 points. So the top dark brown, the center is gray, and the bottom one is tan. You may not tell that in the picture, but we've colored them differently, but we also identify them in text on there. The top one is setting the slack adjuster at 101 degrees. That's the dark brown one. The gray one sets it at 107 degrees. And the tan one sets it at 105 degrees. How do you know what angle to set it at? You have to verify what clevis pin station you have and what vehicle you have. So, on the bottom tan one, that's only used for trailers. No other vehicles, only trailers. So most of us on the phone call may not deal with trailers, so don't worry about the tan one. If you do deal with trailers, you only use the tan one, and only trailers have the 1.38 clevis. However, trucks, tractors, buses, coaches, they will use either the 1.30 or 1.38 clevis pin spacing, and they'll either use the gray template or the dark brown. And the clevis pin spacing will tell you which template to use. The very bottom shows a picture of a tape measure. You don't have to have my template to actually set up a slack adjuster at 101 degrees. We can also use something called BSAP, which is brake slack adjuster position, which is measured linearly in inches. Okay? And let's go on to the next slide. Most trucks, buses, coaches, tractors are set up at a BSAP of 2 3/4 or 2 1/4. And the difference between a 2 3/4 and a 2 1/4 BSAP is a 1/2 inch. The reason for that is the 1/2 inch difference between a long stroke chamber and a standard stroke chamber, size 30. It's 2 1/2 versus 3. That's your 1/2 inch. So we moved the slack adjuster back a 1/2 inch from 2 3/4 BSAP to 2 1/4. That's why we had to change the clevis to a 1.30 to kind of fake out the slack adjuster to think it's still at 101 degrees and not at 107. That way the slack would continue to work properly. That may be hard to understand, but that's the reason we did it. Now, the second bullet point says the majority are set at 2 1/4 BSAP and 1.30 clevis. So the majority, if not all, of MGM chambers and TSE chambers that are welded clevises are 1.30 and have a BSAP of 2 1/4. If that's true, then you can physically measure the position of that clevis. And if you look at the right-hand upper picture, you see 2 1/4 BSAP from the large clevis pin center line to the back of the chamber, face of the chamber. And then the 1.30 is measuring the actual distance between the two clevis openings. Now, what's the bottom picture showing? Well, again, I told you, most of the vehicles today are coming with welded clevises. And if they come with welded clevises, they're set at 2 1/4 BSAP, which is a 1/2 inch shorter than most what we saw 5, 10, 15, 20 years ago. And with a welded clevis, you don't have a backup nut. So if you take a welded clevis off, if you have a damaged chamber and it has a welded clevis, and the only one you have in stock is the same type and size of chamber, but it's a universal that you have to cut off the push rod, and thread on a new clevis, you might run into a problem. Both MGM and TSC will tell you never replace a welded clevis chamber with a universal chamber. The reason is, look at the bottom picture. You now have to get number one, you have to get the right clevis, the correct clevis, which is either a 1.30 or 1.38. But if you took off a welded clevis chamber, it's probably going to be a 1.30. So that means you've got to find a 1.30 clevis in your stock or in a WD or dealer. And I'm going to tell you, they are hard to find because most of them are still speccing and ordering 1.38. So you got to find it first. Now, if you find it, now you got to put it on there and set it at 2 1/4 BSAP and install the backup nut. The backup nut actually might hit the face of the chamber, and the brake might not release all the way. If it doesn't release all the way, you could have a dragging brake. Only for a while, because if it doesn't release all the way, remember, it won't adjust properly, because in order for my brake adjuster to adjust in Haldex's, it's got to come back all the way to an at-rest position. So, what is this saying? It's saying that you should replace a welded clevis chamber with a welded clevis chamber. Why would you do that? Because of what I just told you. However, you would also do it because it saves time. You don't have the technician having to cut the push rod, and again, we're at an hourly rate here, and screwing the push rod, clevis on the push rod with a backup nut, and trying to set that in the correct position. You buy a welded clevis, it's already preset. Next, and you're putting on a new clevis because the old clevis could have been worn. Okay, now a while ago you saw that chambermaid tool, and I told you on the end of it, you can actually stick that end into the center of a spring brake chamber, and if it doesn't hit either one of the clamp bands, it's a long stroke chamber. The same thing could be done with my template. We found this out about, 10 or 12 years ago when MGM was up at our Troy headquarters, and we were playing around. And he said, oh my, he said, the end of your template is actually the perfect size to determine whether you've got a long or standard stroke chamber. So if you look at that blowout there, it says if this end of the template fits between clamp bands of a spring brake chamber, it is a long stroke. So there you go. That tool can be used for several things. Next slide, please. Cannot be used on a service brake chamber, of course, because you've only got one clamp band. Okay, this picture comes right out of Maintenance Manual 4, Meritor Automatic Slack Adjuster Cam Brake Manual, and it tells you what this template, back up one. Oops. It tells you what this template can be used for. You have points 1 through 5, so you can use it for a 5, a 5.5, 6, and a 6.5 inch slack. Now, if you have a 7-inch slack on some of the coaches, you got to use the white template, because the white template is designed to go into the 7-inch slack. Okay, I didn't talk about that because it's very uncommon today. But I want you to look at detail at item 3 and 4 in this picture. If you look, you've got half circle cutouts. And one of the cutouts is the same size as the half of the small clevis pin. The other is the same size as half of the large clevis pin. Well, guess what? That's the tool you use to identify whether you have a 1.30 or a 1.38 clevis. So that tool will be very handy to keep in the parts department, so the parts guy will hand out the right clevis, correct clevis, for that particular customer. So again, you can look at this in detail in Maintenance Manual 4. With that, let's talk about diagnostics. Next slide. Well, we don't talk much about diagnostics because what I'm going to tell you is most of the information about diagnostics would be covered in these 3 particular publications. Again, remember, the first one on the far left side on the bottom, that is the front side of the TP 1363, which is the wheels on and wheels off inspection for foundation brakes for cam brake systems. Again, it covers all the details of different items to be checked. It doesn't give specifications. Those specifications can be found, again, in Maintenance Manual 4 on the far right-hand side. And in the center, that's that Federal Motor Carrier Safety Administration driver's card that does have a Meritor publication number, because I got approval from the feds to reprint that because I thought it was a very handy tool for technicians. So those are the supported publications that you can get from us free of charge. Go on Meritor.com and go to our literature on demand, or send an email to Gina, and we will certainly get you copies for your technicians, so that we're doing a correct, safe job on foundation brakes for commercial vehicles. With that, are there any questions about what we presented today, or anything else on Meritor? Sounds good. Yeah. All set.
Guys, the floor is open. All right. Well, if any questions come up over the next day or two, or over the weeks as you think about this, please let us know, and I will certainly get the questions to Rick and Paul. Be happy to support that and your team out there in the field. This, as they mentioned, will be posted on our YouTube channel for Parts and Service. I expect to have that up sometime within the next day or two, and we'll distribute that link via your RPMs, so you should have that available to share with your dealership locations. If anybody has any questions, please feel free to speak up. Other than that, we'll dismiss for the afternoon. And on behalf of everyone here at Bluebird Parts and Service, Paul and Rick, we appreciate your time and everything that you have provided to us today.
Okay, well, thank you guys for participating. We appreciate it.